Okay, in this video, I'm going to work with a significantly harder problem because it's not in triangular form. Okay, so one of our goals will be to make this into triangular form, and then we will go ahead and solve it, the back part of the problem like we did the previous problem. Okay, so when I look at this, I'm going to make this into a matrix. Okay, so let me just write that right here. The first matrix will be 2, 3, -2, and 6. Okay, the second row would be 1, 2, -1, and 3. Those represent the x, y, z and constant values. And then we'll have 5, -2, 0, and 5. Okay, so you'll want to do the same with your problem. Okay, so remember to keep pausing this video and working through your problem. Okay, now, big difference here is we're not in triangular form. So what we're going to do is we're going to try to first get triangular form. And to do that, we have to first knock these numbers out. We really wish those were zeros, okay, in those positions. And then after we do that, we're going to try to knock that out. So if we had zeros in all of those positions, then it would look like the problem that we had done before. We're also going to want to have ones in all of these positions. So if we have zeros in where the blues are and ones in the other positions, it'll look like the problem that we just did. Okay. Now remember, the first thing we're allowed to do is switch rows. So in this case, I can get a 1 in the right position simply by changing row 2 and 1. So I'm going to rewrite this matrix. I'm going to put row 2 on top. Okay, so I'll have 1, 2, -1, 3 on top, and I'll take the old row 1, which was 2, 3, -2, 6, and keep row 3 exactly the way it is, 5, -2, 0, and 5. And this gives me a new matrix. Okay, so we have one of the goals already. We have a 1 right there. Okay, now we're going to use that 1 to make both of those into zeros. Okay, so how do we do that? All right, let me throw my little bracket here. So there's 1, okay, middle row, and keep on going down. Let me create a little more space here. 1, okay, down to there. All right, so row 1, we're going to keep the same because we're happy about that 1 in the upper left corner there. So we won't do anything to row 1. But we would like a 0 in the front of row 2. Well, what can we do? We can take row 2 and we can subtract 2 row 1s. Okay, so that's 2 times row 1. So when I do that, that will give me a 0 there. Now we need to be careful. For the y column, we start with the 3 and subtract the 2 twice. So we get a -1. All right, and then we'll start with -2 and subtract -1 twice. So that's -2 plus 2. Oh, that gives me a 0 there. All right, and then we have to take the 6 minus 3 twice, and that'll give me another 0. Okay, so row 2 becomes that. Now, in order to get a 0 for row 3, I'll take row 3 and subtract 5 row 1s from it. Okay, so if I want to subtract 5 row 1s, I will go ahead. Let's see what happens. 5 of those will give me a 0 here, as I intended. Okay, and then we have in the y column -2 minus 10, so that's a -12. Right. In the z column, we have 0 minus looks like a -5, so that's 0 plus 5, which is 5, right? And then we have a, in the last column, we have 5 minus 15, so that gives me a -10. Let me just check that real quickly again. So it would be -2 minus 10, correct? Okay, and 0 plus 5, yes, and 5 minus 15. This, I believe, is correct. All right. So you can see we're closer to where we want to be because we have zeros now. We have ones and zeros everywhere in the first column. Now you can see the second row. Now my goal is to get a 1 here and a 0 down below. Okay. Well, getting the 1 is easy. Let's do that in one step. Okay. So all we're going to do is take this matrix, and we're going to leave row 1 alone. Okay, oops, I'm going to have to extend that down a little bit further. Row 2, all I'm going to do is take negative of row 2. So the 0 becomes a 0. We're going to multiply everything by negative 1. So we get a 1, and these remain as zeros. Okay, now the third row, I could get a 0 there a while. Okay, there are a couple of ways to do this, but maybe a really good way to do this for the third row is to take row 3 and add 6 row 1. Oh, no, do not use row 1 again, because that would actually reintroduce an X in the first column. What we want to do is we want to take the old row 2 and subtract 12 of the old row 2. So take row 3. Do not use row 1 again, because that would actually reintroduce an X value in the third row. Okay, so we'll use the second row, and we can say, okay, that's going to be 0, and then we're going to get another 0 here, okay, and then we'll have a 5 and a negative 10. We're almost there, okay? We want to have a 1 right here, and then we'll be in triangular form. Okay, so if that were a 1, we would be in good shape. Well, a really good way to get a 1 is to multiply by 1/5, or you could divide by 5. Right? So we're going to rewrite these the way they were. This was a 1, 2, negative 1, 3. Row 2 is 0, 1, 0, 0. We're very happy with that row a while. All right, and then here's where we're going to take row 3, the old row 3, and we'll divide by 5 or multiply by 1/5 if you prefer, and we get a 0, 0, 1, negative 2. So look at this. We actually are well on our way to the solution. This row tells me that z must be negative 2 and y must be 0, right? So now all that's left is to zero out what's above. Okay, so we can use this 1 down here to zero out what's above. So notice we're working backwards now. Okay, we're going right to left. We want to have a 1 at the bottom in the last row in the z column and get zeros above it. Well, row 2 is fine. It already has a 0. So we want to get a 0 in row 1. Okay, well, how can we do that? We can take the current row 3 and add it on to row 1. So in row 1, we'll take row 1 and simply add row 3. And if we do that, we'll have a 1, 2, we get a 0. And when you add 3 plus negative 2, you get a 1, right? And then you have 0, 1, 0, 0. We'll do nothing to row 2, and we'll do nothing to row 3. Row 3 already gives us a solution for z, and row 2 already gave us a solution for y. So now you can see we almost have the solution for x, right? What we're going to do now is we're going to use this 1 to wipe out the 2 that's above it, okay? That's a relatively easy step to do that. We're just doing elimination, okay, along the way as we do this, okay? So it looks like we want to take row 1 and subtract twice row 2 from it. So we're taking row 1 and subtracting row 2 twice from it. And what will that leave? We'll still have a 1 in the first column because row 2 had a 0 in the x column. And then we'll have a 0 in the y column. The z column, since it's 0 minus twice 0, it's still 0. And then in the constant column, you have the 1 minus twice 0, which is still 1. Okay, so it looks like now we can just copy row 2 and row 3. And we are now in reduced row echelon form. Okay, so we have nothing but 1x, 1y, and 1z in the columns, or I'm sorry, in each row. And so this tells me that x must be 1, y must be 0, and z must equal -2. Okay, so if you kind of ignore the augmented constant column, when you solve this, when you can get down to ones on the diagonal, because that'll give you a 1 for x, 1 for y, and 1 for z in each subsequent row, and zeros everywhere else, you now have the solution. All right, so you do that, repeat these steps with your own problem.